Good morning to all.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning. Good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning.
Sir, is offline confirmed starting on 15? Okay, that is good, sir. And teachers will be the same only, no? So what's the system? Y'all will be going to Andheri and broadcasting from their center, right? Okay. So that is good, finally. आप कब से बोल रहे थे सर एमटी के बाद ही चालू हो जाएगा ऑफलाइन?
They're making the timetable. I have seen yesterday.
Okay, that is
It's
very
rolling
good.
from 14th, not 15th, from 14th, if I'm right.
Okay, that's very nice.
Yes, sir.
सर बट
Thank you,
मैसेज
sir.
बोरी वाली ग्रुप पे नहीं आया अब तक.
नहीं अभी तक टाइम टेबल तो सेट नहीं हुआ because they will give that only after 7.
Sir, matlab you won't come to Dadar.
दादर है.
हाँ सर चलेगा.
सर बोरी वाली.
सर आप वड़ा पाव खिला दो सर, ट्रीट दे दो हमें.
सर बोरी
Sir, वो
वाली.
दादर में previously before the COVID we used to have a canteen underneath. If you people have visited the Dadar center, there is a small, besides the steps and the lift, there is a small space.
Sir, their benches are kept.
No,
Now
that's a big
benches-
space. Where benches are kept is a big space.
Yes,
Besides
sir,
the
there
lift,
is
there
no-
is a small space where we used to have a canteen.
Oh,
Yes,
sir.
sir,
Okay,
that-
sir.
that is still
Thank you,
there.
sir.
There
Yes,
used to
sir.
be only 2 items, sandwich or vada.
sir,
सर
the
पवाई के
wheel.
कैंटीन से एक बार मैंने कोल्ड कॉफी लिया था, वो नेस्कैफे का. मुझे फूड पॉइजनिंग हो गया सर. वो कुछ 5 महीने एक्सपायर्ड था.
Oh shit.
और
तब
मैंने
क्या?
कंप्लेन किया तो उन्होंने बोला यू शुडंट हैव द कोल्ड कॉफी देन इफ इट्स कॉजिंग प्रॉब्लम्स.
Now can expiry date ka, they'll make sure your expiry date. I'm surprised. Something beyond expiry date anytime is a trouble. They shouldn't even keep.
Sir, then वो wheel
Sir,
वाला.
बट
लेकिन
आप
अच्छा है
सर
सर,
सर
finally.
आप बोरी वाली
Sir,
आओ
practice-
सर, मैं आपको हर रोज सीट दूंगा.
Sir, this hafte 2 times we went to college for practicals.
Dadar,
Yes, sir.
Yes, sir. EM practicals. बहुत मजा आ गई sir.
Sir, chemistry are even better.
titration किया है chemistry में?
Yes, sir.
Yes, sir.
Sir,
Color
NaCl
change
and
हुआ है?
H2S. हाँ, sir?
Color change हुआ है?
Yes, sir. Yes, sir. Light pink, sir.
Sir, वो wheel वाला experiment फिर offline class में ही करेंगे ना?
Once the classes are starting, experimental setups, and we are comfortable when you handle the equipment. Online समझाने में वो बड़ा thing.
Yes, sir.
वो सर वो व्हील घुमाते हैं बाद में वो गिरता नहीं है, वो वाला ना एक्सपेरिमेंट. मतलब the wheel is rotated और मतलब
वो experiment है नहीं. Experimental setup कौन सा experiment पूछ रहे हो आप? You will do it
सर
in the.
रोटेशनल में, सर रोटेशनल में एक एक्सपेरिमेंट होता है.
That is gyroscope. वो तुझे syllabus में है नहीं. जो theoretically पढ़ाएंगे, gyroscope आपको syllabus में है नहीं.
वो किस
Rotating wheel, change in angular momentum.
हाँ सर वही मोस्ट.
Now listen. We need to define omega for a rigid body. Finding omega for a rigid body. What is omega? Angular velocity. What is
Yes, sir.
omega? Angular velocity. Right? Suppose you have a body which is moving like this. Every point of the body is moving with the same velocity. Same as that of BCM, BCM, BCM. Then there is no omega. This is pure translation. Translational motion. Then there is no omega. This is pure translational motion. But suppose if there is omega, then VCM is 0 and omega is not 0. This is pure rotation. But remember, body need not be rotating only about center of mass. It can be pure rotation even about another point. For instance, this body is hinged about this point. So velocity of this point is 0, but it has omega. This is also pure rotation. So need not be that the point about which it is rotating must be center of mass only. No, that point can be anywhere, sometimes even outside the body. Sometimes even outside the body, right?
Yes, sir.
Yes, sir.
So in the
for
second case,
poor trans-
velocity of center of mass will be non-zero, right?
Velocity of center of mass in the second case need not be 0. Rather will not be 0
Yeah.
in this case. But there will be one point which will be addressed about which the body is rotating. Then I will call it pure rotation.
Okay, sir.
Sir, can you give an example outside wala?
Will give. Why do you think I will leave it?
Okay,
But
sir.
that will be an instantaneous axis of rotation. I'll come to that at a later.
Okay, sir.
So pure translation will only occur when a force is applied on the center of mass of the body.
Right. Net force is 0. Also pure translation can exist. It may be moving with uniform speed. I can have two forces, one here
Yes.
and one here. Net force is 0. Body is subjected to pure rotation. कभी भी हो सकता है. It need not be through the center of mass.
Yes.
सर सेम डायरेक्शन में होना चाहिए ना, नहीं तो अगर डिफरेंट डायरेक्शन में होगा तो वो ओमेगा स्टार्ट हो जाएगा.
हाँ, right.
Done, sir.
What if the body is subjected to rotation this way? It has got both translation and rotation. Right? It has got both translation and
Rotation.
how do you calculate omega? The first thing and the most important thing. After some time, the body is like this. That means it has got angular displacement.
Yes, sir.
It has got angular displacement. L is the length of the body. I'm taking a thin rod because explaining is easy. It need not be a thin rod. It can be a rigid body of any shape. Right? Now, it has got angular displacement. That means it has got omega. Call this distance as S1. Call this distance as S2. What will this arc length be? Theta is equal to S1 minus S2 divided by L. Theta is a small angle. So this line can be considered to be an arc. Very orthodoxly, this is d theta. Very orthodoxly, this is d theta. Right? But I'll represent it as theta only and so on. So this arc length divided by L. Sector formula. Suna hai kabhi?
Yes.
Yes.
Now, how do I get omega? Theta by t. That means S1 by t minus S2 by t divided by L. S1 by t is V1. V2 by L is omega. Velocity of this is V1. Velocity of this is V2. V1 minus V2 by L, the perpendicular distance between them will be the omega of the body. Very orthodoxly, this will be d theta and this will be d. So ds1 by dt, ds2 by dt divided by L. Are you trying to tell me you have a rigid body like this? You know the velocity of this as v1, velocity of this as v2, and the distance between them is d. Then omega will be v1 minus v2 by d. If it is rotating in clockwise. If it is rotating in anti-clockwise,
V2
this
minus.
is v1, this is v2, this is d. Here it's rotating in clockwise. Here is rotating in anti-clockwise. Omega will be v2 minus v1 by d. If v1 is greater than v2, it is clockwise. If v2 is greater than v1, it is anti-clockwise. But the most important point that you should remember, v1 and v2 should be parallel. And you should know the distance between the two parallel velocities. You mean to say, if I give you a velocity v1 like this, making an angle of alpha, give me a velocity v2 like this, making an angle of beta with the horizontal, and you know this distance to be d, then what will omega be? v1 cos alpha minus v2 cos beta divided by d. So resolving the velocities parallel to each other, resolving the velocities parallel to each other, divide by the distance between the two parallel axes, you will get angular
Omega.
velocity of the body.
Sir, can we also take the sine component for this?
How will you take the sine component? That will be both in the same direction. They will be equal. If you take this one v1 sine alpha and you take this as v2 sine beta, the rigid body should not expand, right? So along d, both should have the same velocity. If a
Yes.
rod is moving this way, this end and this end, along the length of the rod should have the same velocity. And I cannot take that to find omega because the perpendicular distance between them is 0. So
Yes,
that won't
sir.
give me omega.
Got it, sir. Thank you.
Sir, in the third case, it is rotating clockwise, right?
1, 2, 3,
No, sir, fourth case then, fourth case.
4 is, yeah. I took this velocity minus this, it's clockwise. I can take either way. Suppose after taking clockwise, if my assumption is wrong, I'll get a negative sign for omega, negative anti-clockwise.
Yes, sir. So, when offline starts, will there be another test to determine shuffling? Like offline test?
To determine,
Shuffling, sir, like the batches.
अरे नहीं shuffling कब यार, बहुत time इसके.
ये पक्का हार्ट अटैक दिलाएगा.
Sir,
Hmm.
sir, so there should be a parallel distance between the two velocities to get omega, right?
Naturally. Varna v1 is equal to v2. You take the same point. If I take v2 here, v1 is equal to v2, then how will I find out omega?
Yes, sir.
I know the velocity of only one point. I should know the velocity of 2 points. Then I can find out omega.
Sir, here v1 and v2 are instantaneous velocities, right?
Naturally. Only then we'll get omega also to be instantaneous. Orthodoxly, this should be d theta by dt. That's what I told.
Done, sir.
One second.
Done.
So just a minute. Done, sir.
Now let us take an example to calculate angular velocity. This is a smooth wall and this is a smooth flow. There is a rod kept here at an angle theta, and this end is moving with a velocity v. Right? So this point, I don't know the velocity, but I'm damn sure about one thing. This point is moving downwards, right? So this velocity here is 0.
Yes, sir.
Yes,
Yes.
Yes.
What will omega of this particular body be? This velocity minus this velocity divided by the perpendicular distance. V minus 0 divided by L sine theta. Anti-clockwise, because this velocity is greater than this. Right? V minus 0 divided by the perpendicular distance between them, L sine theta. So you mean to say omega is V divided by L sine theta. Yes. You told me something about rigid body theorem in the previous class. With respect to any point of the body, you should get the same omega.
Yes.
Select the two other points, 2 points with in different direction and show me that. Have a look. This velocity is not known to me. Let me assume its velocity is u.
Yes, sir.
Now, if this is theta, this will be v cos theta. This is 90 minus theta, this will be u cos 90 minus theta. This will be u sin theta.
Yes, sir.
Along the length of the rod, along the length of the rod,
Same velocity.
should be the same velocity v cos theta. Along the length of the rod, v cos theta should be equal to u sin theta.
Yes, sir.
Yes, sir.
V cos theta should be equal to u sin theta. Now you want to calculate omega of the body using this velocity and this velocity. Velocity of this point in this direction is how much?
0.
0, sir.
Velocity of this point in the downward direction is u. The
U.
perpendicular distance between them is how much?
L cos theta.
Cos theta.
Now omega, if I calculate u minus 0 divided by L cos theta.
Yes, sir.
What is the value of u from here? V cot theta minus 0 divided by L cos theta. This will turn out to be V by L sin theta.
Yes, sir.
Whichever 2 points in the body you know the velocity, you will get the same omega. Take any 2 points of the body, you will get the same omega.
सर आपने बोर्ड टैप नहीं किया सर इस बार.
सर मैं भी वही बोलने वाला था.
Yes, sir. No.
So 1 more minute.
Now listen. We do the transition into rotation. It's a very strange thing. We will just do the transition into rotation and we will divert ourselves into altogether a different parameter for the next one lecture. Then again we'll come back to rotation. First of all, we have learned how to take the torque equation. Am I right?
Yes, sir.
Yes, sir.
Yes, sir.
You told me was R cross F. I am happy with that. Newton meter. Units, Newton meter. You can calculate the dimensions of torque, not an issue.
Yes, sir.
Now this is an axis about which there is a point mass going about in a circular track of radius r. If I am seeing the top view, the particle will be like this. This is the top view when I am seeing from there. Are you all okay with it?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
I am interested to know torque will be R cross F. R F sin 90. इस sin 90 क्यों डिसाइड किया यार आपने? F and R are perpendicular.
Yes, sir.
Yes, sir.
If force is perpendicular to R, all it will produce is only tangential acceleration. The force which is perpendicular to R will only produce.
Tangential.
Tangential acceleration.
So tangential acceleration is R alpha
Yes, sir.
mr square into alpha. What have you achieved? No big deal here. R cross F लिखा है. F is m into 80. 80 is R alpha लिख दिया. क्या achieve किया? Torque is I into alpha. This quantity is defined as moment of inertia. Moment of inertia. Is it a new word? Yes. What does it represent? What does mass represent in translational dynamics? Moment of inertia represents in rotational dynamics. This is a replica of the equation F equal to ma. Linear acceleration replaced with
Tangential.
Tangential.
acceleration. Force replaced with
Torque.
Oh,
inertia. अभी वर्ड क्यों चेंज कर रहे हो? अब तक मास बोल रहे थे. Mass and inertia. Mass represents inertia. Inertia replaced with moment of inertia.
Moment of inertia.
How do you want me to visualize moment of inertia? It is as good as mass, but in rotation. Greater the mass, greater will be the force you apply to produce 1 meter per second square of an acceleration. Greater the mass, greater will be the force applied to produce 1 meter per second square of an acceleration.
Yes, sir.
Yes.
yes, sir.
Greater the moment of inertia, greater must be the torque applied to produce 1 radian per second square of an acceleration. Greater the moment of inertia, greater should be the torque applied to produce 1 meter per second square of an acceleration. What is measured by mass? When I tell you mass, what will you visualize? Here, a massive body here. To make it move, I have to apply greater force. Agreed?
Yes, sir.
Yes,
Yes,
sir.
In rotation, it is not mass. It is I that decides whether you have to apply greater or lesser torque to make it rotate. Greater the moment of inertia, greater will be the torque to be applied to make it move with 1 radian per second square of an acceleration. We will go into further depth of analyzing I. First, to take it down till here. I is mr square. That means units are kg meter square. Kg meter square. I is moment of inertia.
Sir, it's a scalar quantity only, no?
Actually, it's a tensor. Temporarily consider it to be a scalar because tensors are not taught, but there will be 1 or 2 restrictions when you are adding them. I'll come to that at the right time. Probably it will take 1 more lecture.
So this offline system will be an offline online hybrid, right?
Partly, yes. It is not that alternate days you will have online lectures. It's slightly different from what you are visualizing in schools. In schools, they're calling 3 days, right? Here also we'll call 3 days. These 3 days will be coaching lectures. So the complexity is arranging the faculty now.
So
Sir,
medical
but
batches
college
started
online
now
होना
for
चाहिए, sir.
offline.
No,
Sir,
for all centers nahi hoga, which is centers. Some people are given the option of attending online as well. There is a separate cabin in Andheri office where there is a digital board set up where we can take the class from there. People of the other centers who want to attend the online lectures, for them, that will be through the Zoom lecture only. The digital board which we took class. You people saw the digital board, right?
Yes.
Yes, sir.
It will be from that particular room. From
The medical batches
different
started
centers
now
who
for
want to
offline.
continue, from other centers who want to continue with the same online track, for them the timetable will be from that particular digital platform.
सर तो वीसी से नहीं होगा कनेक्ट बोरी
VC में VC क्यों, तब जिसको ऑनलाइन चाहिए वो इधर सेंटर पर आ सकता है या घर पे बैठ सकता है. इधर वे ही कैन, यू कैन कम टू बोरी.
So we can go from center or home for
Yeah,
another batch.
either of them. The day you are not able to come to the center, you can use the same Zoom link to attend it from home or from the center.
Sir, bus
Sir, in Andheri batch, you will teach or we need to go and sit and see you over the VC?
Which batch?
So if you are in Andheri batch, okay, and then you will come there and
The
teach.
class is separate. Andheri will be live there, for instance. Right?
Yes.
Andheri may will be taking the live lecture. That will be a separate lecture. People who want to opt for online, for them exclusively digital board say we will take one lecture. Suppose I am there in Andheri, morning 7:30 to 9:30 I have taken in one section. Say flagship. 9:45 to 11:45 I will take it in another section, Zenith 1. Who all came for live lecture will be attending the live lecture. Third lecture I will take it for the Zoom students of these two sections. Zenith
Okay.
1, people who are attending online will be attending from that particular digital board.
So it won't be simultaneously
Sir,
online offline for
It
a
will not
single
be
student.
simultaneous. So recording simultaneous. ऐसा नहीं कि I am taking class to the Zenith 1 batch and that will be telecast. वो नहीं हो रहा.
Oh, अच्छा.
sir,
हाँ.
sir, the people who are going Dadar offline and you are teaching from Andheri, so how will that be?
The next day I will be in Dadar.
Acha, so same topic you will teach over there offline for Zenith one. Okay.
Previously we used to do the same thing, right? One day we used to
Okay.
go to Dadar, one day to Andheri. That way we used to do. Same timetable will continue. Only one
Okay.
thing. जिन बच्चों को VC से ही पढ़ना है या Zoom से ही पढ़ना है या ऑनलाइन ही लेना है, for them there will be one exclusive track in continuation with what we are doing.
दूसरे सेंटर्स का क्या होगा?
दादर को सर
दूसरा
आप दादर
centers
को भी
they
पढ़ोगे ना?
will have two options, either attend the live lecture there or the online lecture which we take from Andheri.
So
Sir,
the
आप दादर
faculty
को
will
भी
change
पढ़ाओगे
or
ना?
you will be on video conference for other centers?
So the
For other
faculty,
centers I will be there through the video conferencing lecture.
the faculty मतलब change नहीं होगी ना? For Zenith one, मतलब other day you will take on Dadar and other day on Andheri.
See, you people are getting confused with so many centers. For Dadar, I repeated 4 times, and this is the 5th time you are making me say this. For Dadar, we will be visiting the center, right? Don't confuse the others. Wait for the timetable to come.
So now I can
Sir, with
understand why
this
you would.
offline and online,
You wait for the timetable to come.
sir,
Right.
sir, in this offline and online, would the syllabus of each branch would change? The link between the all branches.
Now you are suppose from which center?
Sir, I am from Andheri.
तो फिर तुझे क्या खींच के एक मारूंगा तुझे
Sir,
second word की
sir,
tension
मैं बोल
है।
रहा हूँ link,
और तुमने
मैं
बाकी
अगर-
लोगों को टेंशन क्रिएट कर रहे हो।
नहीं सर मैं बोल रहा हूँ कि अगर हम ऑनलाइन अटेंड कर रहे हैं, ठीक है, और हमें बाद में एक लेक्चर ऑफलाइन हमें हमारा डोज और सब कुछ हो गया, and then I come offline, so would there be a gap between those lectures or the gap would be
There will
covered?
be little bit of a gap. जैसे कि अभी now you know this little bit of a gap could be half a lecture or one lecture. वो exactly now for example today's lecture talking with you people 10 मिनट ऐसा waste हो गया, तो 10 minutes lag है।
हाँ सर।
So exactly it will not be the same. थोड़ा इधर उधर होगा अगर if you keep jumping between online and off.
Okay sir, got it.
Sir, आपका पीड़ा समझ सकते हैं sir. You'll have to teach the same chapter some 6 times, the same topic.
This we used to do once upon a time. ऐसा नहीं कि for us it is new. That's the reason why the wordings that we use while repeating the concept will be the same.
Yes, sir.
There were nine sections only in Andheri. तो आज 3 section लिया, कल 3 section लिया, तो 2 consecutive days same thing you are repeating 3 times daily.
सर मैंने आपका 2016 का लेक्चर देखा तो सेम क्वेश्चन सर अभी का और उसका सेम ही है, मतलब
Obvious
कोई
syllabus change नहीं हुआ तो हम कहाँ change करें?
सर क्वेश्चन सेम, वर्डिंग सेम।
Please, ये जंक कॉल्स आजकल बहुत ज्यादा हो गया है।
सर लेकिन ये बहुत अच्छी बात है सर। कि अभी ऑफलाइन हो रहा है, इतने टाइम से वेट कर रहे थे इसके लिए।
शानदार खबर आरबीएल बैंक से आपके लिए क्रेडिट कार्ड सैंक्शन. Now listen. Suppose I take a rigid body. You took a point object and you explained, right? You took a point object and you explained. Now explain for a rigid body. Mass m1 at a distance of r. Mass m2 at a distance of r2. Mass m3 at a distance of r3. M4 at a distance of r4. M5 at a distance of r5, so on and so forth, up to mn, nth particle. Torque is equal to r cross f, r into f into sin 9. R into f is m80. Suppose the particle is going in a circular track like this. Observe this. This is m1. This is r1. It is going in a circular track like this. It has an angular acceleration alpha. So particle will have tangential acceleration 80. When you see the
Yes.
top view, this will be a circle. When you see the top view for M1, M1 is a particle, this is R1. If it has got alpha, this will be R1 alpha.
Yes, sir.
Yes.
So F is M into 80. Why are you not taking centripetal acceleration? मैं सिर्फ tangential ले रहा हूँ, तभी तो ये 90 degree होगा. I am taking only tangential, only then it will be 90 degree.
Yes, sir.
Yes, sir.
Now this is M R 80 will be R1 alpha, R1 M1. More orthodoxly, Mi, Ri, Ri. This can be the first particle M1, second particle M2, third particle M3. So net total torque, this is d tau, this is d tau, this is d tau. Integral d tau will be sigma of Mi, Ri, or write it as torque only. Sigma of Mi, Ri square alpha. I goes from 1 to n. You dealt with for one particle, Mi, Ri, 80. For different particles is different because R will change. 80 is equal to R alpha. Right? 80 for the ith particle is Ri into alpha. Magar alpha for all the particles is the same. ऐसा कैसा बोल दिया यार तूने? Alpha for all the particles will be the same. Rigid body theorem. All particles of the rigid body will have the same angular displacement.
Velocity.
Yes.
Hence same angular velocity and hence same angular acceleration. So alpha, whether it is for the ith particle, second particle, or the nth particle, will be the same. This quantity is what you call as moment of inertia. For a single particle, it is m into r squared. If there are n particles, it is summation of mi ri. If there are n particles, it is summation of mi ri squared. Moment of inertia of a rigid body. Now the tricky situation is different shapes will have different moment of inertia. Ring का moment of inertia अलग है, disk का moment of inertia is separate, hollow sphere is different, thin rod is different. In linear dynamics, I never had a necessity to invest 2 lectures on mass of a body. Mass of a body is mass given in the question, simple. Here, moment of inertia we need to calculate for different bodies. Different shapes के लिए formula for moment of inertia will be different. So I need to know the formula before I can start rotational dynamics. This is the diversion for next 1.5 lecture. We need to calculate different moment of inertias for different bodies. Only then we can start rotational dynamics. This is a replica of the equation F equal to ma. Linear acceleration replaced with angular acceleration. Force replaced with torque. Mass replaced with moment of inertia. Rather, inertia replaced with moment of inertia.
So sir, here I is the summation of MI/RI square, right?
Perfect. MI/RI square.
Sir, I have a doubt.
Well,
Sir, if like that body is rotating very uniformly, so then when you look at it, when you look at an individual particle from the top view, that will be in uniform circular motion, right?
in uniform circular motion, there is no alpha,
Yes, sir.
so there will be no torque. Torque is I alpha.
Oh, okay, sir, fine.
Now, Earth is rotating with uniform angular velocity. Since how many years? Millions of years?
Yes.
Yes, sir.
Yes, sir.
No alpha. It is rotating with uniform angular velocity. It will continue to rotate unless there is an external force to stop the Earth. Earth will be rotating in it. There is no force which is making Earth rotate. The force which is making Earth go around the sun is gravity. But Earth to spin about its own axis, what is the force? What is the torque? Nothing. Zero. It's rotating with uniform angular velocity. Something is moving with uniform linear velocity. What is the force acting on it?
Zero.
Something is rotating with uniform angular velocity. Torque acting on it? Zero. One second, I'll be back in a minute.
Okay, sir.
Can I rub the board?
Yes, sir.
Yes, sir.
Now here, remember one thing. Students feel MI/RI square. Let me consider the center of mass of the body and assume whole of the mass concentrated there. That m into distance from the axis whole square. Don't you think I'll get moment of inertia? I'll not get. I'll show you the example. First example will be that of a thin rod. thin rod. Thin rod is rotating about this axis, omega. I want the moment of inertia. The formula should be remembered. Finally, after deriving all this, I'll summarize them on the board. You have to remember this formula. I'll tell you, you have to remember. Right? First
Yes,
of all, thin rod, consider a small element dx at a distance of x. Mi ri square is moment of inertia, right? Mi, ith particle is this. Di is dm into x square. Mi ri square?
Yes, sir.
Yes, sir.
yes,
Of this, it is not discrete particles, it is a continuous body. So I'll have to integrate
Yes, sir.
mass per unit length into dx into x. Unitary method, mass per unit
Yes,
length.
sir.
Yes.
yes, sir.
Yes, sir.
Least value of x is how much?
Sir, zero.
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 Zero, sir.
Minus
Zero.
L by. Maximum value of x is L
L
by.
by 2.
Yes,
X
sir.
per least value is minus L by 2. Maximum value is L by 2. Mass per unit length x square dx minus L by 2 to L by. This is x cube by 3. This will be mass by 3L x cube L by 2 whole cube L cube by 8 minus of minus L cube by 8.
Yes, sir.
2 times L cube by 8 will become L cube by 4.
Yes, sir.
Yes, sir.
This will become ml square by 12. Moment of inertia of a thin rod about an axis passing through the center. ml square by
12.
12.
12.
Well,
any one of you plan to consider whole of this mass concentrated at its center of mass. What will this distance be? L by 4?
Yes.
M into L by 4 whole square, you will get the.
Wrong answer.
Wrong.
So do not assume that whole of the mass appears to be concentrated at its center of mass. That is only for translational. In rotation, whole of the mass need not appear to be concentrated at its center of mass. Now, one more interesting thing. तो हर बॉडी का मोमेंट ऑफ इनर्शिया हमें पता होना चाहिए. हाँ, पता होना चाहिए. स्टैंडर्ड स्ट्रक्चर्स तो डिराइव कर देंगे. If the paper setter gives you a tricky situation, you have to calculate the new moment of inertia. Thin rod ka always it is ml square by 12. You change the axis, moment of inertia will change. You change the axis, moment of inertia will change. Dekh lo, if you take a thin rod, dx at a distance of x, di is integral of dm into x square. Mass per unit length into dx. Here what will be the limit?
0 to L.
12.
0 to L.
Mass per unit length integral x square dx is x cube by 3 0 12 ml square by 3. Same thin rod, moment of inertia about an axis passing through the center is ml square by 12. About one extreme end is ml square by 3. So depending on the problem, moment of inertia will change. Yes, it will change. In translational dynamics, I didn't have the problem. However, the body moves, mass of the body is the mass of the body. It will not change. Unless it is variable mass like a rocket propulsion. Right? Here, change the axis, moment of inertia changes. Change the axis, moment of inertia changes.
Sir, ml square by 12 is axis passing through the center, right?
ml square by 12 is the moment of inertia when the axis is passing through the center of the rock. ml square by 3 is the moment of inertia when the axis is passing through one extreme end.
Yes, sir.
So even college will be full-fledged offline, no?
College obviously.
सर वो तो कॉलेज तो हाइब्रिड मोड पे स्टार्ट हुआ ना.
College में I think they'll put up both the.
हाँ सर उनने साथ में क्या सर मैं एकदम क्या.
साथ में they are doing it live and offline both simultaneously. कैमरा उसी क्लास में लगा दे रहे.
Yes
सर पहले भी किया था.
Yeah, that is
And sir,
not
what
very
about
effective.
college exams, sir? What about that? Will it be online or offline?
हाँ sir.
College exam is online.
वो गूगल फॉर्म था ना.
नहीं
Google form
UT2
पे.
के बाद finals वाले उसको कब.
No,
that would be
final
offline.
college exams will be offline. Be clear about it. Your unit test this month will be offline online.
Online.
But final college exams will be offline. You'll have to go to the college and write.
सर उसका ऑनलाइन करा दो.
नहीं, मेरा हाथ में नहीं है.
हाँ सर
मुझे
UT
कल
के लिए
पता
offline
चला-
करा लो भले
सर
सर.
एक बिटकॉइन.
चुप है, मेरा हाथ में नहीं है वो. चुप.
सर मुझे
सर
कल
107 बिटकॉइन.
सर बिटकॉइन दे देंगे.
NFT अभी.
सर अभी नया आईपीओ जा रहा है उसका हम दे
रिश्वत
देंगे शेयर.
देने की इतनी आदत पड़ गई कि कॉलेज एग्जाम्स का शेड्यूल तक चेंज कर दो. कल को बोलोगे आकर मेरा बगल में बैठ के मेरा कॉलेज एग्जाम लिख
हाँ
दो,
सर,
मैं
कर दो.
Bitcoin
अरे
दे
अच्छा
दूंगा.
है.
वो भी प्रॉब्लम नहीं है हमको
अच्छा
सर.
है.
नहीं
सर
होगा.
हम लोग टॉप मारेंगे.
सर कल पता चला मुझे कि हम लोग क्या वी हैव सम अ कांसेप्ट ऑफ अ क्लास टीचर इन कॉलेज.
क्या कर क्या रहे थे दो दिन.
हाँ सर मुझे भी कल पता था, ग्रुप पे आया
मेरे को
था.
नहीं पता कौन है.
सर 11th का
मुझे
फाइनल
भी
एग्जाम्स
पता
कब
नहीं
होगा?
यार. This I am also not aware of.
Sir, same
सर क्लास टीचर कौन है सर वो नहीं पता सर. पता है कोई तो.
ये भी नहीं पता था है कोई.
They must
Sir,
be
college
keeping
में
a
तो-
track of your attendance and all that. You may not be aware of it. We don't know. I am also not aware of a class teacher concept.
सर कॉलेज के फिजिक्स में तो SHM वो सब कर दिया है सर. वो पता भी नहीं क्या चालू.
एसएचएम कर दिया.
एक
क्या?
कॉलेज
का फिजिक्स लेक्चर लास्ट हुआ कभी था?
तो सर मेरे को पता भी नहीं टीचर
ये
कौन.
बंदे को
अरे भाई.
कॉलेज का टाइम टेबल पता नहीं.
अरे
सर
अलग ही
हमको
वंडरलैंड
टीचर्स ही
में
नहीं
सर.
पता.
लास्ट 2-3 बार लेक्चर से तो सिर्फ
टीचर के नाम ही नहीं
कंप्यूटर के
पता
लेक्चर.
सर हमें.
सर नहीं सच्ची
सर
में
मुझे
नहीं पता
सर मुझे
आपको लग
फिजिक्स
रहा है कि
एग्जाम
हम
के
लोग
दिन
मस्ती
पता
कर
चला.
रहे हैं, बट नहीं पता सच्ची में क्या चल रहा है, कुछ नहीं पता है.
सर
मुझे
पता नहीं
physics
फाइनल्स कैसे जाएंगे सर. मेरे को तो लग रहा है
सर,
बस EM में
कॉलेज-
एग्जाम दिया.
फाइनल के
देना
बाद तो अटके
पड़ेगा,
हैं हम.
उसके लिए मेहनत करके आ जाओ. कॉपी
तो
नहीं
वही लोग जो
चलेगा.
कॉलेज में टॉप
नहीं सर वो
जब जो
तो कर
हो गया
लेंगे
तो
सर.
हो गया.
सर कॉलेज लेक्चर्स के दिन तो सिर्फ वो नींद निकालने के लिए करते.
अरे भाई से
Fine. Is this over or not?
Yes,
Sir,
sir.
one more minute, sir. One more minute.
Sir, does it mean it is easier to rotate a rod about the center than one of its ends?
You mean your definition of ideal is which requires lesser torque, right?
Yes.
Yes. If definition of ideal is requiring lesser torque, yes.
सर जैसे डोर को हम एकदम एंड से ओपन कर दे तो इजीली ओपन होता है और वन हिंज से ओपन करते हैं तो बहुत टफ है.
Right.
Sir, this was the rotation we learned in 10th standard.
Yes
ना
sir.
आसान सा give reasons 2 मार्क मिल जाता था. Why are
Yes, sir.
doors hinged at their
सर
end?
10 से नहीं, ये तो 6 से ही जा रहा था कब से. तो
अब तक जो चैप्टर सीखा है आपने 10th और इसमें जितना डिफरेंस देखते हो, अभी इस चैप्टर में वो डिफरेंस विल बिकम 10 टाइम्स. काइनेमेटिक्स आपने 10th में भी सीखा है, यहाँ भी सीखा है, कितना डिफरेंस है. न्यूटन्स लॉस तभी भी सीखा है, यहाँ भी लिखा है, कितना डिफरेंस है. मगर अभी इस चैप्टर में दिस डिफरेंस विल बिकम 10 टाइम्स मोर.
सर CBSE में तो ये पढ़ाया भी नहीं था कभी.
CBSE में भी कोरोना बैच they removed this, but CBSE में है.
So we had a chapter called forces in which they had done moment of force and stuff.
Yes,
right.
sir.
Moment of force is for car crosser. It is your college syllabus also ऐसा ही था.
Sir, they did couple.
हाँ sir, couple arm, this that.
हाँ सर.
सर बट वो निकल गया था. का most part
Now that you raised this word couple, which generally I come to it in the next class, let me define torque due to a couple. We defined a torque.
Yes.
Yes, sir.
Sir.
Yes.
Cross F.
The what?
Yes sir. R cross.
R cross F.
Yes, sir. Yes, sir.
R cross F.
So your voice
We
was.
learned how to take a torque equation. Yes or no?
Yes,
Yes,
sir.
sir.
Now, there is something special about this torque due to a couple. Two. There are 4 words in the definition. All 4 are important. थोड़ा ध्यान से सुनिए, don't miss on this. This is important not just for physics, for your life. 2. Equal, unlike, parallel, non-collinear forces produce a torque due to couple. First word,
Equal.
second word,
Unlike.
third word,
Parallel.
Parallel.
Non-collinear.
Non-collinear.
Now, firstly, look at the beauty in the definition of this. The 2 forces should be like this. They should be equal. Unlike, they cannot be in the same direction. If you take same direction, the body will not rotate at the first place. They should be unlike. 2 vectors which are unlike will be in opposite direction.
Yes, sir.
Now listen
They are
carefully.
anti-parallel.
Right? They are parallel. Anti-parallel की चिंता मत करो. That is accommodated in the word unlike.
Okay.
Unlike में opposite दिखा दिया आपने. उसके बाद फिर negative of negative नहीं डालो. So they are parallel. You cannot have one force this way and one force this way. Then what will happen? Center of mass will have acceleration in the tangential direction.
Yes, sir.
Yes, sir.
All said and done, if you have 2 forces, both are equal, both are unlike, both are parallel, the body will not rotate.
Yes.
It should
Yes,
be
sir.
non-collinear. How important all 4 words are?
Yes, sir.
Yes, sir.
In the movie 3 Idiots, Amir Khan makes a mockery of the definition of a machine. हम लोगों ने सीखा है. Every word is important. Ironically, if you get the right prof in NLT, he will teach you the importance of every word. It's easy to make a mockery in a movie. Mockery of कुछ भी कर सकते हो. Somebody says be good, do good, उसका भी mockery कर सकते हो. Right? Little does he know the importance of these words. Every word is important. Simplify that. अरे हद हो गई. जिसने वो definition बनाया पागल थोड़ी. Right? Lord Kelvin's second law of thermodynamics. Second law of thermodynamics statement कभी सुना है आपने?
Yes, sir. Chemistry.
Yes, sir.
You cannot extract work continuously from a body without the help of an external source by cooling it to a temperature lesser than the coldest of its surrounding. Every word is important. एक word miss किया आपने, definition will change. Who defined this here? Lord Kelvin. पागल थोड़ी है Lord Kelvin. You cannot extract work continuously from a body by cooling it to a temperature lower than the coldest of its surroundings without the help of an external source, by cooling it to a temperature lower than the coldest of its surroundings. Every word is important. Right? Definition, the way it is given, you have to remember it. I will introduce my own language. I will, ये सब liberal ideas बोलने में अच्छा लगता है, implementation के लिए marks नहीं आए. You get into IITs, they'll screw your happiness off if you miss even one single word in it. Best example I'm telling you for this. You miss one word, your definition is wrong. Yes or no?
Yes, sir.
Yes, sir.
Now, ये वर्ड कपल का इतना इंपॉर्टेंस क्यों है यार, ध्यान से सुनो. Take the torque about any axis, it will be the same. देख लो. And take the torque about 2. This distance is L by 2, this distance is L by 2. Torque about 2. F into L by 2 plus F into L by 2. कितना आया? F into L आया कि नहीं?
Yes.
This is giving me clockwise, this is giving me clockwise. So I added both of them. Say something.
Yes, sir.
Yes, sir.
Now take the torque about P. This force will give me 0.
Yes, sir.
Yes, sir.
This will give me F into L.
Yes, sir.
Yes, sir.
Take the torque about Q.
Same, sir.
F into L.
Yes,
Yes,
sir.
Yes.
Take the torque outside. यहाँ पर ले लो. This distance is X. This L is L. Call this point S. Take the torque about S. This F will give me anti-clockwise. Yes or no?
Yes, sir.
Yes,
Yes,
yes.
sir.
Minus F into X. This force will give me
Plus F.
clockwise. Plus F into L plus X.
L plus X. Yes.
Yes, sir.
Yes, sir.
Take the torque about this. F into 3L by 4, F into L by 4. Add both of them. F into L.
Yes, sir. Yes, sir.
Take the torque about any axis, it will be the same. That is the beauty in the torque due to a couple. अब ध्यान से सुनो. Second year जब magnetism चल रहा है, there are a few Irdov problems where he will take the torque about 2 different axes and he will equate them. Only then you will get the answer. Their students will keep scratching their head. यार पागल हो गया Irdov. Torque about that axis ले लिया, torque about this axis ले लिया, equate कर दिया. Open your eyes and see, that is torque due to a couple. You will find two forces which are equal, which is unlike, which is parallel, which is non-collinear. So torque about different axes will be the same. वो कब use कर रहा है Irdov? In the chapter magnetism. Rotational dynamics में ये concept इसके बाद use नहीं करेंगे. कब use करेंगे? Magnetism में use करेंगे. Don't forget. Is this point clear?
Yes, sir.
Yes, sir.
Something more important for you people in this age, it will appear like a joke. हंसेंगे आप लोग. But this is the essence of life. The word couple in English to describe a male and a female is derived from physics. Now again read the statement.
Equal.
Unlike.
Parallel.
Unlike physics doesn't recognize gay marriages. Law recognizes. Physics doesn't recognize. It must be.
Unlike.
They should be able to think parallel. In the two, both think in two different directions. It will not make an ideal couple. Non-collinear, don't fight about every aspect. Then alone it will be a couple. I have taught you how to select your life partner. I have earned my right to be invited for your wedding. Yes or no?
Yes, sir.
Small doubt.
Don't forget to invite.
के पास आप ही
Any
fund
one
कर
of
दो.
you are planning
follow
for
this?
destination weddings, air tickets भेज दिया कर. इंडिया में कहीं पर भी मैं आ जाऊं, पेरिस में कहीं पर कर रहे हो तो एयर टिकट्स भेज. आई बात समझ में?
Follow this.
Yes,
Yes,
sir. Yes, sir.
देंगे सर एयर इंडिया.
Make a note of it.
सर वो शिवाज को बोलो फिर.
अब ये रूल को पक्का फॉलो करते हो ना बस.
किसका नसीब कब टर्न होगा कभी किसी को पता नहीं. Right? Mind and life are unpredictable. So let it flow the way it comes. Right? We don't brand people into boxes. He will be going to Paris. He will be going to US. क्या पता when life will turn, which angle of your situations we don't know.
सर आपने हमें गाड़ी चलाना सिखाया, शादी करना सिखाया.
और है सरफेस टेंशन के बाद कपड़े धोना सिखाऊंगा, बर्तन साफ करना भी सिखाऊंगा. सरफेस टेंशन होना है उसके लिए. राइट?
Yes, sir.
तो आप क्या क्या सिखाओगे
क्या
हमें
मस्त
अभी?
ट्रेन कर.
I will make you completely eligible to get married. Don't worry.
सर आपके पास इतना बिटकॉइन है सर, शादी का पैसा भी आप ही दे दो ऑर्गेनाइज करने के लिए।
Thank God. तेरा
पहले
शादी
सर
का
को भेज
खर्चा भी मुझसे ही लोगे तुम। हद दोगे। कुछ भी नहीं, एयर टिकट्स भेजा करो। If it is
हाँ
just
सर।
wedding.
प्राइवेट जेट भेजें।
सर आप
Private jet
गए
की
हो क्या
जरूरत
कोई
नहीं।
स्टूडेंट की शादी में?
प्राइवेट जेट की जरूरत है नहीं। I will sit in domestic plane in a concession rate and I'll come. Don't worry about all that. Send normal air tickets.
सर बहुत मेहरबानी है सर।
सर भेज दी।
अब हाउ टू सेलेक्ट ए लाइफ पार्टनर सिखाया और वेडिंग के लिए एयर टिकट्स नहीं भेजोगे, दोगे यार।
यस सर।
सर आप गए हो किसी स्टूडेंट की वेडिंग में?
बहुत सारे। Because those occasions will be the only occasions when I can see whole of the batch. वरना मिलना ही नहीं होगा।
यस सर।
Torque due to a couple का most important significance is take the torque about any axis, it will turn out to be the same. So two different axes पर equate कर सकते हो if and only if it is torque due to
कपल। सर 106 का अटेंडेंस है आज।
Actually मैं देख रहा था बीच में 109 तक था and those idiots are idiots who missed the definition of couple of उसको क्या समझाओ 109 तक था बीच में and
Sir,
before
उनका divorce हो
when I
जाएगा।
was starting this they bunk. अब क्या बोलेंगे नमूने, they don't even know when to bunk.
Starting
Or if you look at the
89.
definition from just an English perspective, everything is an oxymoron, like equal, unlike, फिर parallel और non-collinear.
Hence, physics is divine. It teaches you life.
Yes, sir.
Yes, sir. Done.
Can I rub the board?
यस सर।
There are two important derivations: parallel axis theorem, perpendicular axis theorem. As far as JEE syllabus is concerned, derivation हमारे लिए कोई मायने नहीं रखती. And you should know how to apply. But as far as your HSC is concerned, derivation is the most important thing. Every year they ask you this parallel axis theorem. But rotation for you in HSC is there in 12th. So 12th boards में this derivation guarantee पूछेगी. Right? So you have to learn this derivation. Not for the JEE syllabus, but for your HSC. But first of all, what is parallel axis theorem and how do we apply? Parallel axis theorem. We need it to solve problems on moment of inertia. First, let me explain what is parallel axis theorem. This is center of mass. I want the moment of inertia about the point P for this body. What do I need? I need the moment of inertia about an axis passing through the point P. Parallel axis theorem tells me I about P is equal to I about C, provided the two axes are parallel, plus M into D square. Parallel axis theorem tells me I about P is I about a parallel axis passing through C plus M into D square. Two conditions which are compulsorily to be fulfilled. One, these two axes should be parallel. Second, this must be passing through
Center of
C.
mass.
Center.
C.
mass.
Center
This
of mass.
must be passing through center of mass. Two conditions should be fulfilled. These two axes must be parallel. Tomorrow, you ask me, I want I about P. Then I should know I about C this way. This distance should be D. I about P is I about C plus M into D square. The two axes must be parallel. Second, this must be passing only through the center of mass. You give me a body like this. This is C. This is A. This is point P. I about P is I about A plus M into D square will be wrong. This must be passing through
Center of mass.
When I derive this, you will see in the derivation why it should be passing through the center of mass. Right?
Yes,
Then
so
derive this. The derivation is there in your HSC syllabus and in your 12th boards, it's a guarantee question. When you are writing your 12th boards, when you get this derivation, remember. But first of all, validity of this. Validity dekh lo. What did you tell me moment of inertia of a thin rod about the center of mass is ml square by
12.
12.
Suppose I need moment of inertia about this axis. This distance is how much? This is L by 2.
L by 2.
I about this axis will be I about C ml square by 12 plus m into L by 2 whole square, m into D square. वही तो बोल रहे हो?
Yes, sir.
Yes,
Sir.
This is ml square by 12 plus ml square by 4 turns out to be ml square by 3. Is that the answer that you are expecting?
Yes, sir.
Validity of parallel axis theorem दिखाया, proof नहीं दिखाया. Take it down, we'll go to the proof.
Can you repeat the statement for it?
I about P is I about C plus M into D square. D is the distance between the two parallel axes. I about C is the moment of inertia of the body about its center. Statement you will write this way. Listen carefully. Moment of inertia of a body about an axis passing through a point is equal to the sum of moment of inertia of the body about a parallel axis passing through the center of mass and product of mass and the square of the distance between them. A statement as it is आपको boards में लिखना है. That I'll dictate with the derivation. Right now, concentrate only on how to apply. I will stop here and take up the doubts of conservation of momentum. I'll start from exercise 4. एक्सरसाइज 4 सभी ने अटेम्प्ट किया है?
Yes, sir.
Yes, sir.
Yes.
कुछ 6-7 डाउट्स है।
कर देंगे. Every day half an hour, last half an hour you give all the doubts will be over. Exercise 4 से we'll come back to exercise 2. I think exercise 1 का कुछ problem हुआ है.
Right.
सर वो
Yes, exercise 1 is done.
Sir, advanced
Sir,
paper
wait.
2 doubts are left.
So one more minute.
1 minute.
Sir, so you are showing the derivation in this class or next class?
Next class करेंगे.
Okay, sir.
अभी
So have you ever taught in the HSC college?
नहीं. कई रिव्यू करते थे. वो सिलेबस यहाँ कवर कर रहा हूँ, फिर वहां क्यों कवर करना है 2-2 बार?
सर आपने बोला था आप registered हो ना as a college teacher over there.
Yeah, no, all these lectures are officially considered to be college lectures.
Oh.
That's why your attendance you are being saved.
ये तो बहुत अच्छा हुआ फिर.
सर बोर्ड्स और जी कैसे मैनेज करते हैं बच्चे, समझ नहीं आता.
मैं जिस तरफ कर रहा हूँ, बोर्ड्स भी कवर कर रहा हूँ, जी भी कवर कर रहा हूँ, तो दिक्कत क्या है आपको? फॉलो मी.
Done, sir.
एक सेकंड, बुकलेट खोल रहा हूँ. Can I have the board? COM booklet exercise 4. First 25 problems में book.
The
25.
question 13. 13, sir.
12B.
Or 12B.
25. 31.
First 25 में book.
29.
सर 15.
First 25 मतलब 29 is lesser
Sorry,
than
sir. Sorry.
25. Now listen. 12th question. ध्यान से सुनो. This is a thin rod. You have disturbed the rod. There is no friction. Center of mass will be falling vertical.
Yes, sir.
That everybody knows. Now, how to find the equation of the trajectory of this? This is theta. This distance you have given me as r. This is center of mass, and this is the origin. So, what will x be equal to? X is this distance. L by 2 cos theta minus r cos theta. L by 2 minus r into cos theta. Y is L by 2 sin theta. Squaring and adding both, will I get x in terms of y or y in terms of x?
Yes.
Once you know that, you know the general equation, and hence part B of 12th question is done.
So over here, how will you eliminate theta?
Squaring and adding both of them, sin square theta plus cos square theta, I thought is 1. Repeat
Sir,
that.
it is, but sir, matlab you can't take anything common over here because over there it's L by 2 minus r, right?
Alright, bring this to the denominator. We have x by L by 2 minus R
What? हाँ यार.
equal to cos theta. 10 बार लिख के
हाँ
imposition
ठीक है. Sorry.
y by L by 2
हाँ
is
समझा.
equal to sin theta. Can I square and add both
Yes,
of them?
now you can.
Yes.
Sorry.
Now you can do. If I bring this to the denominator,
हाँ सर समझा.
COVID batch.
Sir,
Coordinate geometry था.
Can you add 31 and 29 too?
अरे
अरे first 25 problems है.
अरे चैन नहीं होगा उससे.
25.
Can I rub the board?
Yes.
Yes sir. सर आपकी बुद्धि चाहिए होगी सर एक दिन.
क्या आपकी
बुद्धि सर, इसमें 20 मिनट लगाया था ये क्वेश्चन पे और आपने 20 सेकंड में सॉल्व कर दिया.
ऐसा कुछ होना चाहिए जिससे हम
फर्स्ट टाइम
ब्रेन कर
सॉल्व
सकते.
करते हो, फर्स्ट टाइम सॉल्व करते हो, किसी को भी थोड़ा टाइम लगेगा. हालांकि you also once conics is done in mathematics, this is a child's play for you. That is general equation, this art of conics, you will do in maths millions such type of adjustments. Now listen. In work energy theorem, you solved this question. There the question asked was, from the unstated position, what distance should I suppress it so that this takes off from the ground?
Yes.
Yes, sir.
There the value turns out to be 2 mg by k, if I remember well.
हाँ सर वही.
आपको value
Yes.
से क्या लेना देना है यार? Now you suppressed it by 7 mg by k. मतलब you suppressed it to such a great extent that I'm damn sure that this mass will leave contact with the surface somewhere down the lane.
Yes.
Yes, sir.
इतना interested क्यों हो यार आप उस situation के लिए कि this mass should leave contact with the surface? भाई साहब, when it leaves contact with the surface, normal force will become
Zero.
Mass will move with constant velocity.
at that instance. If I know the velocity, thereafter center of mass is subjected to only one force called gravity.
Gravity. Yes.
Yes, sir.
So when the mass comes somewhere here, this distance is y. Small m leaves contact with the surface. I'm keen on that instance. So that means from the unstructured position, it goes up to a distance of y. Elongation in the spring will be y. If it is equal to mg, y is equal to mg by k. So when y is equal to mg by k, small m will leave contact with the ground.
Yes.
Yes, sir. Yes, sir.
At this instant, I want the velocity of small m here. क्यों भाई साहब? Why do you need the velocity there? तभी तो center of mass का velocity calculate कर पाऊंगा.
Yes, sir. M1 V1.
Total mechanical energy here will be half k 7 mg by k whole square plus kinetic energy will be 0 plus gravitational potential energy I'm taking 0. I'm taking this as the reference line. Gravitational potential energy कहीं पर भी reference line ले सकता हूँ. Oh God, I'm again sanctioned a credit card. हर 1 घंटा कोई फोन करके credit card sanction कर. Listen, half k x square 7 mg by k plus kinetic energy plus potential energy. Right? Now, what is, are you people able to hear me?
Yes,
Yes,
sir.
sir.
Total mechanical energy here is half mv square plus half k y square mg by k whole square plus mg h. What is h? This plus this. You took this as the reference line. From here to what height did it go? This plus this. It will be 8 mg by k. Are you able to see that part of the board?
No, sir.
Abhi,
Yes, sir.
Yes.
the mechanical energy here is kinetic energy plus elastic potential energy of the spring plus gravitational potential energy. If I equate both of them, the only variable here is V. Yes or no?
Yes.
Yes, sir.
Yes, sir.
Once you know that variable V, velocity of center of mass at this instance is mv plus m into 0, this m into 0 divided by m plus m. I know velocity of center of mass. What is the maximum height to which it goes? Vcm square by 2g.
Yes, sir.
Yes,
Yes, sir.
Sir.
Yes, sir.
Yeah.
Sir, I have a silly question. So over here, why do we use VCM square by 2g? Because like in the sums where there are two balls and then they are being thrown upwards, that time we can't directly write the maximum height attained as like this, right?
We did. You dropped a body from the top of the tower, you threw a body from underneath, you calculated center of mass. What is the height to which center of mass has gone? This is what you have done. You didn't calculate the maximum height of this ball and this ball separately because both need not reach the maximum height simultaneously.
Oh, okay, sir. Fine. सर ये तो बहुत मस्त फॉर्मूला हो गया सर मैं तो हर का डिस्टेंस ऐसे इंडिविजुअली निकालता था और फिर डिफरेंशिएट करता
बहुत
था
लंबा पड़ेगा.
हाँ सर वही टू फाइंड मैक्सिमम एंड मिनिमम
Yes, sir. Done.
So one.
Center of the board.
Yes, sir.
25.
सर इसमें सॉल्व करने का मेथड पता है लेकिन वो बहुत लंबा जा रहा है. डू यू हैव अ
हाँ सर, वो रिजॉल्व करना बहुत
कुछ भी 45 डिग्री रिजॉल्व करना दिक्कत हो रहा है आपको. ओ 45 डिग्रीज का बिगेस्ट एडवांटेज, अगर गलत भी किया सही आंसर है.
25 not 26.
हाँ सर 25
सर लेकिन बात तो सही है, 45 में अच्छा रहता है. यू कैन ब्लाइंडली टेक 1/√2.
बेटा ये तो पुलिंग डाउन द स्टैंडर्ड ऑफ कोऑर्डिनेट शुरू हुआ आपका.
हाँ यस.
यस सर.
टू आइडेंटिकल बॉडीज, राइट. I'll draw the diagrams, उसके बाद देख लो. There are two identical bodies. This is m. This velocity and this velocity is how much? I cap 2j cap. This velocity is how much? Minus I cap. I cap minus I cap plus 3j cap. And this line is along which line? This is I cap minus j cap. That means with the horizontal, this line I cap minus j cap. What angle will it make? 45 degrees.
45.
Oh,
सर अब हो जाएगा.
there are one class of people or students who should be motivated. Come on, you can do it. Come on, you can do it. कर ले. One class of students need to be instigated. वे गधे हो यार, तुमसे नहीं होगा बोलने से उसका ईगो चल जाता है. The problem with you people is you people have reached sainthood. Saints are neither can they be instigated nor motivated. They are 45 degree resolving के लिए you people need hint. Upside down in the evening for half an hour without fail. Now, see, this velocity, when I resolve along this direction, that velocity will remain unaffected.
Yes sir.
yes.
Yes,
So अभी समझ में आता है कैसे करते हैं.
sir. Yes, sir. Along tangent.
Now these two velocities along the common normal will be subjected to conservation of momentum
Yes, sir.
and small.
And
Yes
restitution.
sir.
Restitution.
Yeah.
So now it's easy. Now it's fine. So what I had done is I had not written it as 2j cap in the vertical direction and I cap in the horizontal direction. I just wrote it as one vector with some direction and then 2I cap plus 2j cap. So it became here.
Deserves a bigger punishment.
Yes, sir.
Sir,
$5 लिख लो मेरी अकाउंट में.
सर बिटकॉइन सर.
अरे यार बिटकॉइंस पर 30% टैक्स लग रहा है. यूएस डॉलर्स लिखो काफी है.
Sir, but Bitcoin appreciate भी तो करता है.
1 बिटकॉइन की वैल्यू बहुत ज्यादा है.
इतना इंफॉर्मेशन रखते हो आप लोग पैसे के बारे में. मुंबई dominated by Guju thought process. Mumbai is totally Guju thought.
Dhruval Gujju ही है.
They have good knowledge of how to make money. $29 जिसने पूछा भी डाउट.
क्लास में करा.
क्लास
में करा.
Sir, I have a
उसका
small
B वाला
doubt,
part.
sir.
हाँ.
I have a small
Second
doubt
bit,
here.
maximum height to which it rises, I will not say. वो बड़ा आसान है. Collision के बाद conserve momentum and find out the velocity. Maximum height तो आ जाएगा. उसमें ना impulse है ना कुछ है. The velocity with which M2 strikes M1. M2 है कि M2 strikes the lower
हाँ सर
mark.
वो हो गया था.
वो कैलकुलेट करना ही ट्रिकी पार्ट है जो मैंने क्लास में किया है.
हाँ.
बाकी इजी पार्ट मैं नहीं करूँ. इल्ले नो.
I have a conceptual doubt here. So you told that when the string is taut, the V5 momentum finally is 0. Can you explain that in this question 29?
मैंने नहीं बोला है. You bought it here. When it comes here, till here it was a free fall. You know the velocity. This velocity component will be destroyed because of this impulse. this velocity component will survive. Because of this, you will find out the velocity at the lowermost point. अब याद आ रहा है?
हाँ सर.
किया है कि नहीं हमने?
Yes.
$5 लिख लो अकाउंट में, भूलने का नहीं.
सर 30th में एक डाउट था सर, आपने क्लास में करवाया था सर, आपने बोला था कि एक मेथड है वो आप मतलब डिसाइड करोगे करेक्ट है कि नहीं.
हाँ मतलब बोला था क्लॉकवाइज ले लो.
You will get the answers there. You will get the answers. If you are taking this, you are firing this, you conserve momentum along this direction, initial momentum and final momentum, you get the answer, but the transition you will not get. At which instant with the impulse, the string becoming taut will be difficult. So if they're asking only for velocity, you can conserve momentum in anti-clockwise or clockwise. But in this question, you have to continue doing to find out the intermediate state.
Yes sir. Maximum height.
We have solved up to 30th question. From 31, I'll take up in the next class. Last half an hour will keep for doubts. So piecemeal wise, whole of conservation of momentum will be over, because it will take at least 3 or 4 lectures before I can give homework from rotation. So till then,
Okay.
all the people who have got backlogs, please complete it. This is your last chance to finish your backlogs.
Yes, sir.
Clear?
Yes.
रीजन
No.
पूरा थोड़ा याद करना पड़ा.
क्या याद करना पड़ा?
सर 27 भी डाउट है सर, आपने बस 25 तक बोला था तो मैंने 27 बोला नहीं.
27.
हाँ
एक
सर
मिनट.
27.
27. Conserve momentum between C and A first.
Okay sir.
Now you know the velocity of A
Yes sir.
Yes sir.
is found that the instant A and B are the same. So instant and velocity of A and B are the same means that will be maximum compression.
हाँ sir. Yes sir.
हाँ हाँ.
So आ गया.
Okay,
And
understood.
you can conserve momentum between C and A because spring ka force is non-impulsive, right? In the
Perfect.
moment of collision. Okay, sir.
First conserve
sir.
momentum between C and A. You get the velocity of A. Once you know velocity of A and B का maximum compression state apply कर लो. Both will acquire the same velocity.
So that reduced mass wala formula has to be the best form, shortcut wala formula.
That will be, if you can apply that, nothing better than that. Those steps
Yes,
में
sir.
answer आ जाएगा.
वही तो sir.
Yet you don't get, tell me in the next class, I'll solve it on the board. Not an issue.
Okay sir.
So वो reduced
will
mass
be
wala
sending
formula
the
college
recording of
exams
this
में applicable नहीं है ना?
Wish you all a happy weekend.
Okay, sir.
So you will be sending the recording of this lecture.
Okay, I'll send it. Not an issue.
Oh, sir, and thank you for conveying to Gautam sir to give us a holiday on Monday. ये MT के बाद actually दे दिया.
Yes sir. Thank you sir.
Yeah, thank you sir.
lecture रख दिया.
Welcome, welcome. Anytime.